In this short video I'm going to demonstrate how to construct a nested projection using several projection cameras at different points along the path of the shot camera. As you can see, I've got a new script open here, and if you look at it, it's the original script template that I started with for my demonstration on the basic projection setup in Nuke. Okay, the only difference is that I've swapped out the original checkerboard for my shiny new custom checkmate node, which obviously I can use to select different colours, different coloured checkerboards, and that's going to be important for this projection because I'm going to be using several projections. Okay, so I'm going to start by taking all these nodes. I'll ignore the merge map node for now because I'll put that in later on. So I'm going to, whoops, I don't want to clone those, I want to select them, I want to copy them, and then I'm just going to come over here out of the way of those swatches and paste them. Okay. By the way, that's my checkerboard node. It's gone like that because the postage stamp is unchecked, and so that saves a little bit of computer resource, but for the sake of what I'm doing, it's relatively insignificant. Okay, switch that back to 0, which means it'll be back to the grey, or at least I hope so, back to the grey checkerboard. Not quite sure why that's not defaulting back, but anyway, I think maybe there's just a little bit of a lag. Okay, so what I'm going to do then is I'm going to use this. I'm going to basically set up a basic projection. So here's my scanline renderer, which is the bottom of the stack, and my shot camera goes off that, and then my geometry connects to the object, and then from that my project 3D node feeds the geometry, and then from that comes the image on one side of the input pipe and the projection camera from the other side. Okay, so let's just take a look at this. This node is bugging me, so I'm actually going to delete it and I'm going to bring a new one in and scrub this one down and hook it up. Not quite sure why that's not giving me the grey one, but it's not important for this demonstration, because I've got plenty of other colours to be going with. Anyway, this is my basic projection. If we take a look at this in 3D, I'll just come around to the side a little bit so that we can see this a little bit more detail. Let's take a look at what's happening. So we can see here that I've got my projection camera. Got my projection camera, which is, as I scrub in, it looks like that was actually drawn from the shot camera at frame 70. I'm going to be deleting that shortly, and we can see our shot camera has this dolly push, which comes right out here, and it actually goes through the projection camera and in quite close to world space 0, which is where our checkerboard is sitting. Okay, I actually think the camera dolly is useful, so I'm going to keep that animation on there. What I am going to do though is I'm going to delete the projection camera because we're going to be creating a new projection camera. So I'm going to create this nested projection broadly observing the powers of 10 model. Although I won't be following the mathematics quite so rigidly, I'm going to allow the resolution of my project to determine the mathematics relative to this specific project. Okay, I want to start by just closing off these nodes and then just type in S to bring out the project settings. And I just want to refer to the full size format. We can see that the full size format here is 2K format, which is 2048 by 1556 pixels. So that is the resolution that is in the scanline renderer at the end of the process. That's what is rendered and presented to the viewing audience. Okay, so that represents our optimum resolution. Now, normal industry practice for matte painters, unless they're instructed differently, is to create a matte painting which is double the final display format. Okay, So I'm going to emulate this by creating a reformat node. And I'm going to position this under the matte painting, and I'm going to create myself a format that is specifically for this. I won't. Okay. So in my reformat node, I'm going to come down, create a new format, and I'll just name it for now. I'll just call it double res, and I'm just going to double up these width and height ratios. So I can do that just by using the multiplier operator, and just put that in, and we can see that that doubles up the aspect ratio. So if I settle for that now, we can see that the reformat node has got our double res format applied there. So effectively, if this was our matte painting now, this would be double the resolution of the display format. Now that's not to say that you could do this with a matte painting. You actually need your matte painting to be of that resolution before it's even brought into Nuke. There's no point bringing in a P-size image and then using a reformat to up its resolution. You're never going to generate resolution that way. It has to be of that resolution to start with. But for the sake of what we're doing here, it's quite acceptable just to sort of double this up actually with a reformat node, because this is basically an infinitely scalable element. Okay, so the premise here is that every matte painting is larger than the display resolution, but when viewed through their individual projection camera, each will then begin to degrade when the magnification exceeds in this case, because we've doubled up the resolution, when the magnification exceeds 100% or twice its original scale in relation to the boundary of the shot camera. And we can use this graphic, which is the screen boundary. We can use this as we're going along to help us with working out the relative scales. So by the time we get to the point where the magnification of the projection is exceeding that amount, then we're going to be swapping out to a nested projection and adding in a second checkerboard. Okay, before I go on, I'm just going to add a pre-mult node after the reformat and put it in. And the reason for that is that I'm going to be basically using a process by which I'm setting up these nested projections for blending, in which case I will need to be exploiting the alpha channels, and therefore I will need to have a pre-mult on there. What this means basically is I can take both these nodes and clone them, and just clone them across, and that way I'm saving myself a little bit of time and effort. So let's start the process. So at the moment we have this projection which currently doesn't have a projection camera. So I'm going to start by creating a projection right out here, right out at the distance, which is at frame 1. So I've scrubbed the timeline out here. I'm now going to copy this shot camera and paste it. In fact, I will name this. Shot camera. Okay, and then this is my projection camera from frame 1. So I'll name this ProjCam, and I'm going to put a 1 as a suffix so that I know exactly what frame this was generated from. I'm going to kill the animation by right clicking in space here and choosing no animation on all knobs and confirming that, and then I'm just going to bring down the swatch, and I'm just going to recolor it so that there's absolutely no ambiguity about which is a projection camera, which is the shot camera. So we can see now that on frame 1 we've got these two cameras. We've got our projection camera, which is now rigid, and then we've got our shot camera, which is moving through. So if we switch to our shot cam, and we take a look at this, we can see that at the first frame, then the entire image fills the screen. We can see with this dotted line around the edge there, and we can see that as it comes in, then obviously we're zooming in on it, and therefore we're testing out its resolution. And of course, at some point out here, we can already see as we move up here, then we're losing resolution. We can visually see softening and pixelating of this image. And obviously, if this was a bigger projection, then and the shot camera was moving in even closer, this would really mess up. Okay. So let's find ourselves a really agricultural way of working out this resolution. So if we start here, I'm not going to count all the way across, I'm going to count halfway. If we start to count across the squares that are in our checkerboard, okay, we can see that we've got 16 squares running from the halfway point across here. Okay. So what that means essentially is that if we scrub along here, once we get to the point where there's only 8 squares across between the center point and this dotted line, at that point we've achieved the maximum resolution. So if I come across this, look, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'll try and remember that one. So if I come across here to this position, which is frame 60. 1, 2, 3, 4, 5, 6, 7, 8. At frame 60, I'm now exceeding the resolution of this projection, and that is with a matte painting that is double the size of the display ratio. So what we want to do is we want to intervene, but we want to intervene actually before we get to this stage, because we don't want to be taking it right to its limits, and also we want to be able to overlap our projections. This is the whole point of layering them. We want to be able to overlap them because we have to blend these in. If this was an image, then we would, or a series of images that blend, then we would need to obviously blend these in using various image manipulation methods, and we would need the overlap. That's critical for that process, and that's the reason why I put the pre-mult in, is because of that very process, because we're always looking to blend the images in when we have a nested projection. So what I'm going to do is I'm going to come back to the point where we've got 10 squares. So let's come back. So we've got 10 squares at frame 45. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's our dotted line. So at frame 45, we've got an extra 2 squares of resolution there for overlap. So I'm going to create a second projection camera at frame 45. So I'm just going to copy that and paste it. And again, I need to go into its properties, rename it, ProjCam, and again I'm going to suffix that name with the frame number. I'm going to kill the animation, and then I'm going to give it a colour, which again is entirely optional, but I find it's helpful. Okay, so now I'm going to copy the checkerboard. I'll just select that and double click it and just choose a colour there. So that's the new colour for this. I'm going to take my reformat and pre-mult nodes and clone them. Okay, didn't do them both, but that's done them both. So I've got both of those. Plug both of those in, and then I'm going to make a copy of my project 3D node, and again that receives the input from the matte painting, or the checkerboard in this case, and the input from the projection cam. Now I'm going to come across to my merge material, copy that and paste it, and I'm going to make sure that I'm projecting this new high resolution, or not necessarily high resolution, but high resolution from this camera position version, and I'm going to make sure that comes in on the A side of the pipe so that it's over this one. So that comes in here, and then that image, then that material, should I say, then goes in into the geometry. Okay, I accidentally created myself a dot node there. I just wanted one just to straggle this across. So we can now take a look at this from the perspective of the scanline renderer. So if we come out to the beginning, to the first frame, we can see our original matte painting there filling the screen, and as this progresses, we'll get to the point where at frame 45 the new matte painting fills the screen, and there we go. So that, the idea of that is a successful nested projection. So we need to do this again. I'm just going to disable that first one, just so that there's no confusion over the squares, and then I'm going to come forward again until I've now got 10 squares again between the halfway point, the midpoint, and the edge of the boundary. It's best to do this in 2D view from the perspective of the shot camera. So at that point, what have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 12. So just going a bit further. Okay, so in this particular case, that happens at frame 73. So it's at frame 73 that I'd need to be switching out to a new projection camera from this particular frame. So again, I'm just going to take my shot camera, I'm going to copy it, paste it, rename it projection cam, and again append with the frame number, which is 73, good reminder, and then I'm going to make a copy of those nodes and connect the projection camera. I didn't recolour the projection camera, which doesn't appeal to my sort of OCD, and then I'm going to copy the merge matte node, and again I want to be bringing this new projection over the top of the original projection, so I'll just make a little bit of space and bung that in, and again I'll just break out with a dot node just to tidy up the whole script, and then I'm going to come to my checkerboard node here, and I'm just going to scrub on a little bit to give myself a new colour. So I've got myself a blue colour now. So if we come out to the beginning of this projection, the reason why that isn't changing is because I haven't killed the animation on this shot camera, so I just need to make sure I'm back in there and set that to no animation and kill that off. Okay, I can turn that checkerboard back on so we see the green one from the beginning, and we can now see the 3 projections in there, and if I scrub forward quite quickly there, we can see that at frame 73 our 3rd projection now fills the screen, and we can now see it at full resolution with the 16 squares across there. So that's the 3rd successful projection. So again, I want to just go forward again and see if we get to the end before we run out of space. What's this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it isn't. So at frame 90 again we run out of resolution. So we need to do this one more time. So again, I'm just going to copy those nodes there, put them in position, and again just make one more merge matte, and again that needs to be going in and bringing in the new projection on the A side, and then bringing the B side from this composite of projections which is sort of been building up behind it. Okay, don't need that dot node, I just need to drag this one down a little bit. Okay, and I'll just put my viewer directly on this and just scrub the yeah, well, I've not used that one so far, so that will do. Okay, so back onto my scanline renderer, and again make sure that I'm on frame 90 because I need to make the final projection camera. So I'll copy and paste this. Again I need to follow the steps just as before, so hook it up, select it, name it. So projection camera, and this one was taken from frame 90. Kill the animation, which was the mistake I made before, and thankfully I spotted it fairly quickly. Recolor. So at frame 90 this now fills the screen, and if we just scale back we can see this was the projection that was initiated at frame 73, then this was the projection that was initiated at frame 45, and then this was the projection that was initiated at the first frame. Okay, so I took the liberty of pausing the screen capture software so that I could cache this this sequence. We've basically got four 4K nested projections here, so it did need to process quite a bit of resolution, so it did take about a minute, which I'm sure you didn't want to watch sort of the caching taking place. But we can now sort of see this, and we can scrub this so we can see our projection sort of happening in front of us there. We can see that even though we're going in really close to this particular card, we're maintaining resolution because we're swapping out with new images that are actually being projected from closer to the camera and incrementally closer to the camera. So hopefully you can see how this projection evolves and how it could potentially allow us to zoom infinitely in and out of an image. Now we could have create one single huge image, but I think the reality of that would be it would be very difficult to create, and it certainly would be prohibitive in terms of resource intensivity. It would probably break the software trying to create something like that. It would be incredibly slow, and probably wouldn't even render unless you were on some kind of supercomputer. So I'm hoping that you found this explanation helpful. Personally, I found the experimentation required to produce this video incredibly interesting and informative. So I'll break here.